Okay, we'll look at some of the homework problems in section 12.3. There are only two problems that I've assigned out of that section 12.3, which deals with the additional constructions. But these two only deal with some of the geometric figures and how to identify the value of x, or find the value of x here. Like in this problem here, you want to find the value of x when you're given this parallelogram here. Okay, now I'm going to show you how this is done. Compare this side to this side. In a parallelogram, the opposite sides are equal to each other. We know that this length is 9. That means that this entire length is going to be 7. So what I want to do here is find out the length of this small part right here. And I'm going to mark off this part that I want to find, or the length of that small section that I want to find, which is right here. I know all of this is 9. I know from here to here, that's 7. So if I subtract 7 from 9, I'm going to get 2. So this length right here is going to be 2 inches. Okay. Now I can find out what x is. From this part right here, all the way down to this vertex, that's 7 inches. This part that I found out was 2. So to find out what x is, subtract this 2 from the 7. And that will give you 5 inches. So that means that the value of x is 5 inches. So this is where x is, and that's going to give you 5 inches as the answer. Okay. So that's how we find out the value of x from a parallelogram that looks like this. Okay, here's another problem, and this one's a little bit different. Some car jacks are constructed like a collapsed rhombus. When used to raise a car, the rhombus is easily seen. If the sides of a rhombus are 22 inches, what is the maximum length of that shaft? Okay, so here's the shaft right here. We want the maximum length. If this rhombus was to be collapsed completely, if it was collapsed completely, and of course in a rhombus all the sides are going to be congruent, so if this side is 22, then this side must be 22 inches as well. So if this is collapsed completely, what I'm going to do is add 22 and 22 together, and that will give me 44 inches approximately. So the maximum length of this shaft will have to be 44 inches. Okay. So those are the only two problems that are in section 12.3, and hopefully these two examples will assist you in doing those two problems.